Hello, I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft. So now in this video, we are going to take our discussion forward and talk a little bit about independent processes and cooperative processes. Okay, so let's take a few basic definition and we'll easily understand the concept with that. So two processes are basically said to be independent of each other if the execution of one process does not affect the execution of another process. Okay. And with that, we also have the concept of cooperative processes. Now, two processes are said to be cooperative if the execution of one process actually affects the execution of another process. Now, these process needs to be synchronized so that the order of execution can be guaranteed. So the idea of independent processes is very simple. Two processes, they are not dependent on each other at all. So it doesn't matter which process is executed first and which process is executed after that. They are entirely independent of each other. Hence, their execution does not affect each other as well. With that, we also have the concept of cooperative processes. Now, two processes are said to be cooperative if their execution is dependent on each other. Now, since two processes are dependent on each other for their execution, you have to make sure that these processes are synchronized. So that the order of execution can be guaranteed. It's not like since this process is dependent on this process and you're trying to execute this one only first, which is wrong, right? If this is dependent on this, then this one should be executed first so that after that this one can get unblocked and basically carry on with its execution. So that is what the concept is about independent processes and cooperative processes. Next, what are the advantages that we get if two processes are basically showing cooperation, right? If the processes are dependent on each other, we want to make sure that there is cooperation happening between both the processes. So what all advantages do we get if we do have that? First is information sharing. Since there are several users who are interested in the same piece of information, for instance, a shared file, we must provide an environment to allow concurrent access to these types of resources. Sometimes it may happen that there is a certain piece of information, right, in which several users are interested in. So for that, we should make sure that we provide an environment so that multiple processes or concurrent access to these resources is possible. Second is the concept of computation speed up. So if we want a particular task to run faster, we should break it into subtasks, okay? And each of these subtasks will be executing in parallel with others, okay? Such a speed up can only be achieved if the computer have multiple processing elements. Okay, such as CPUs or IO channel. So let's say there is a process which is a very big process, right? You can break it down into small tasks, wherein some tasks require IO channels. So those particular tasks will go to the IO channel. Some will require the CPU channels and those will go into the CPU channel. So that you can do the execution parallelly by breaking a big task into small tasks. And that actually speeds up the entire cycle of a processing. Third advantage that you get is modularity. Right? So we want to construct a system in a modular fashion, okay? Dividing the system functions into separate processes or thread. We always want to make sure that the entire system is modular, okay? Modularity is a very, very important concept. We want to divide all the system functions into separate processes or separate threads so that each process or thread has a separate task to perform that it can execute in silos or independently. The fourth advantage that we get is convenience. Even an individual user can have many tasks to work on a particular point of time. Okay, this is a real life example. A particular individual may have many tasks to execute at one point of time. For example, a user may be editing, printing, and compiling in parallel. Okay, concurrent execution of the cooperating processes require mechanisms that allow processes to communicate with one another and to synchronize their actions. So what happens is, if you want to execute multiple processes, okay, there are a lot of cooperating processes which interact with each other, right? They are cooperative processes. So you want to make sure that each of them have a lot of tasks, right? And you want to make sure that the concurrent execution happens, okay? For that, you should have relevant mechanism, or the relevant mechanisms that we put in place basically helps that the communication between processes is quite smooth and quite synchronized, so that they can actually, you know, take all of their actions parallelly in a synchronized way, so that no action blocks the action of the other process. Okay, so that is what the overall advantages we get if we have good cooperation between processes. If it's an independent process, then we don't really matter, right? They can execute the way they want. But if we have cooperative processes, we want to make sure that they execute in a synchronized way. And these are all the advantages that we get if the processes are really executing in a synchronized way, right? We can share our information very easily between processes and between users. There is a speed up of the execution of tasks as well, because we break down tasks into smaller tasks. There is good modularity of system that we need to construct, and there's a lot of convenience in terms of how the concurrent execution or cooperating processes tries to communicate with each other and to synchronize their actions with the other processes. Okay. So this pretty much concludes our series on the concept of processes. Next, we are going to talk about different CPU scheduling algorithms. So we talked about the concept of scheduling. We talked about the different types of schedulers we have. And now would be a good time to talk about the CPU scheduling algorithms, right? How do we pick up a process which are all in the ready state and start their execution in a certain manner, in which we are taking care of all the important properties as well. Okay, so that's what pretty much the concept over here is. Thank you so much for taking a look at this module. I hope it is clear to everyone and gives you a good picture of how you should be executing the processes as well. What's a process, what's a program, and all the things related to these information. Okay, so thank you so much for taking a look, and I will definitely meet you in the next module. Bye.